This building didn't collapse from an earthquake. It didn't burn. It wasn't demolished. It rotted from the inside. And it started with rust. Steel feels permanent. We trust it to hold up bridges, skyscrapers, parking garages, foundations. It carries thousands of tons. So how can something as thin as orange dust bring it all down? Rust is not just surface damage. It's a chemical reaction. When iron meets oxygen and moisture, it transforms. Iron oxide forms. And iron oxide takes up more space than the original steel. That expansion is the real threat. When steel rusts, it doesn't just weaken, it swells up to 6 times its original volume. Inside concrete, that expansion creates pressure. Concrete is strong in compression, but weak in tension. Rust pushes outward. Cracks form. And once cracks form, water enters faster. Acceleration begins. Water reaches deeper. More steel is exposed. More rust forms. More expansion. It's not dramatic. It's gradual. A hairline crack today becomes structural failure years later. Rust doesn't need force. It uses chemistry. Most modern buildings rely on reinforced concrete. Steel rebar hidden inside gives the structure strength. But once moisture penetrates the surface, the steel is no longer protected. The building begins breaking itself apart. From the inside, the damage is invisible until it's too late. Parking garages collapse. Balconies detach. Bridges weaken. Not because of sudden impact, but because rust expanded slowly, year after year. It is structural erosion in slow motion. And then something else happens. Cracks allow water to linger. Moisture collects. Dust settles. Moss grows. Plants anchor. Roots follow. Rust opens the door. Nature walks in. What was once rigid steel becomes brittle, fragmented, softened. Vines climb exposed beams. Green spreads across abandoned frames. Steel decays. Life adapts. Steel looks invincible. Rust looks harmless. But chemistry is patient. And once corrosion begins, it does not reverse. Buildings don't always fall with noise. Sometimes, they dissolve.